Today we're going to be discussing geometric sequences. What is a geometric sequence? What is and how to find the common ratio, and an example. Alright, so let's just jump right in. What is a geometric sequence? Okay. So I'm just going to give you a simple example. 8, 16, 32, 64. This is a geometric sequence. Okay. Now just by looking at it, you're going to say, well, it's just numbers, right? And yeah, it is just numbers, but it's a sequence of numbers that has a specific pattern to it. Okay. So that specific pattern is what the common ratio is. And in order to find the common ratio, right here, common ratio, we do the second term over the first term. Okay? Now, if you just look at the sequence, you can tell that it's being multiplied by 2, but we're just going to confirm that, okay? The second term in this problem is 4. The first term in this problem is 2. 4 over 2 is 2. Okay? So, if we look at this, the general form of a sequence looks like this. A times R, A times R squared, A times R cubed, so forth. And I apologize, R is the common ratio, okay? So, let's use this general form here, along with what we learned about the common ratio, to explain this sequence here, okay? So, I'm going to write it again. A is the first term, right? So, our first term was 2. Our second term is A times R, okay? So, A is still 2. What is R? Our common ratio is 2. And again, A times R squared. Well, A is still 2 because A is the first term. Okay? Oops, sorry. 2 times R squared. Well, we said R already is 2. So 2 squared. Sorry, I keep doing that. 2 times 2 cubed. Okay? Now keep in mind that R here is 2. So R is here, R is here, and R is here. Here, here, here. That's R, okay? And A is just the first term in the sequence. In this case, A is 2. A is the first term. There's A right here. There's A. Okay? Now let's just simplify a little bit. 2 is just 2. 2 times 2 is 4. 2 times 2 squared. Well, 2 squared is 4. 4 times 2 is 8. 2 cubed is 8. 8 times 2 is 16. And as you can see, this sequence here matches this sequence here. That's the general form of a geometric sequence. And I just showed you how we did it. Okay? So let's go ahead and do another example. Just find one. Just going back really quick, what most people will do is they're going to see the sequence and they're going to say, you should always do all of this, right? This is the safest way to always get the right answer. But people will say, oh, from 2 to 4, it multiplied by 2. Multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. That's what people will tend to do. And I guess in some cases it will work. But you will find a time when it won't. Okay? So let's go and do an example. Let's say we have a sequence 9, 27. Let me see. 81. Okay, we'll leave it there. So just by looking at it, you can say, well, from here to here is times 3. From here to here is times 3. 3 times 3 is 9. 3 times 9 is 27. From here to here is times 3. But let's go ahead and do the math the way I just taught you. Okay? So R equals second term over first term. And in this case, it's going to be 9 over 3, which is 3. Okay? That's our ratio. Now, according to what we know already, we know that the general form is A times R squared, A times R cubed. So in this case, A is going to be 3, because it's the first term in the sequence. We'll do 3, 3, 3, 3. Multiply, multiply, multiply. And our ratio, which is R, is going to be 3 squared, 3 cubed. Okay? Now we just do the math. 3 is just 3. 3 times 3 is 9. 3 squared is 9 times 3. 3 times 9 is 27. 27 times 3 is 81. You might want to check that 81, because I did it in my head and I'm not sure if it's right. But as you can see, this sequence here is the same as this sequence here. Same thing. Okay? So I guess depending on what the question asks you, the question may say, find the next 3 terms. So you can do one of 2 things. If that's the case, you can say, okay, I know that, like here, it jumps by 3 every time. You can say, okay, times 3, times 3, times 3, times 3. And you could keep getting that number. This number times 3 gives you that one. Times 3. Hey, looks like happy faces. Anyway, you could do that, or you can just use this formula here. Okay? And yes, I understand that this one is easier, but again, that's up to you. Okay? I showed you both ways, and I showed you both could work. Okay? So, what is a geometric sequence? We did that. Show you what is and how to find the common ratio. What's that? And we went over an example. We did that as well. All right? And don't forget the common ratio is how it's growing. Okay? And this is specifically geometric sequences. All right, guys? So hopefully this was helpful. If you have any further questions, let me know. Peace.